So welcome to topic 6, numeration, number sense, mental computation, and place value math. The next, looking at the symbolic algorithm, and the symbolic algorithm I've just got on the slide, prepared to save a bit of time. So let's have a look at how the symbolic algorithm goes, and you'll notice that the way we do the symbolic algorithm is similar to the way we did the last step in the mathematics language stage. Now, the algorithm that I'm doing is a little bit different to the one that Romina did in the lecture. If you like the way she did it, that's fine. I just find this way is a little bit easier to explain to students. I just set it out a little bit differently, and hopefully it's a little bit clearer. So the first step in the symbolic algorithm is to think of the 37 as 37 ones. The second step is to work out what the place values are. In base 5, we have a ones house. We always start with a ones house in any base. We then multiply, because it's base 5, we multiply by 5 to get the 5 house, multiply by 5 again to get the 25 house. So what I've got to do now is I've got to think 37 divided by 25. 37 divided by 25 is equal to 1. So I put a 1 up here, and I think, okay, 1 multiplied by 25 is equal to 25. So I've used 25, and I have 12 ones left. So now I look at the 12, and I've got to divide by 5. What's 12 divided by 5? That's right, it's 2. So I put a 2 in the 5's house. That 2 is actually worth 2 multiplied by 5. So that gives me 10 that I've used. So I have 2 ones left. 2 divided by 1 is equal to 2. So I can put a 2 in the ones house. 2 by 1 is 2. Subtract the 2, and I have 0 ones left. So just to finish the problem, I can write that 37 base 10 is equal to 122 base 5. So I just thought it would be easier to look at the materials demonstrations and work our way through the language stages before looking at this symbolic representation of converting 37 base 10 to 122 base 5. Just put a tick if you're happy with that symbolic algorithm. Now that brings us to the other question. Yes, you will be asked something like this on the exam. People's understanding of place value is not all it's cracked up to be. We function with place value quite well, but we don't necessarily have a deep understanding of place value. And by sticking your nose into another base, it makes you think more carefully about what you know about base 10. All right, so let's have a look at what happens with a larger one here. So again, we think of it all as ones, and we then have to look at the place values that we're going to use. Because it's base 5, we start with a ones house as always, and then multiply by 5. 1 by 5 is 5, 5 by 5 is 25, 25 by 5 is 125, 25 by 5 is 625, and so on. So what we have to do is think, okay, 1,245 divided by 625. So we can work out how many 625s we need to represent. So as I was saying, 1,245 divided by 625, that's going to be only one lot of 625. We subtract 625 and we've got 621 left. We now have to think 625 divided by 125. Okay, we can think, okay, well, it's probably going to be 4. How can I check? Well, double 125 is 250. Double 250 is 500. Yes, so that'll fit. Okay. So 620 subtract 500 will be equal to 120. So 120 divided by 25. Okay, that's 4, isn't it? Because we know that 4 by 4 by 25 is equal to 100. And so now I've got 20 ones left. 20 divided by 5, we know that's equal to 4. So 4 by 5 is 20, and we've got 0 ones left. Now, does that mean we finished the question? Does that mean we can stop now? No, we can't stop because we haven't done anything with the ones house here. We've got to put in a 0. Can you see the importance of the placeholder? Because if we don't put the 0 in here, we would have those other digits, the 1, the 4, the 4, and the 4 in the wrong position. So we have to put in the 0, and it's worth 0, of course. So we end up with 1,245 base 10 is equal to 14440 base 5. So I don't know if any of you worked that out before the tutorial at all, but there's the answer to that question. If you really understand base 10, you're going to transfer some of the skills and concepts across to other bases. So let's go look at 24 base 5 add 3 base 5. Sorry, wrong. I can't say 24 because it's a base 5 number. 24 base 5 add 13 base 5. 20 words like 20 and 13 have no meaning in a base 5 system because they only mean something in base 10. So sorry about that mistake. Well, let's have a look at the addition. Okay, how are we going to set it out? Just the same as we set out a base 10 one, except we're going to have ones house and a fives house. I've got 3 ones. We start in the ones house as always. 3 ones add 4 ones is equal to what? 7. Okay. Can I put a 7 in the answer in the ones house down here? No. What's the largest digit I can put in a base 5 ones house or any house? Is a 4. Now, in base 10, I traded when I had 10. In base 5, when am I going to trade? I'm going to trade at 5. So I've got 7 ones. I'm going to trade 5 ones for 1 5. So on the next slide, I have traded 5 ones for 1 5. I put the 1 5 up the top here, just like we do with base 10. And I've got 7 subtract 5, 2 left in the ones house. The fives house, and see I've got 1 5, add 2 5s is equal to 3 5s, add 1 5 is equal to a total of 4 5s. Can I put 4 in my answer down here? Yes, I can. So I end up with 4, 2, base 5 is the answer to the to that addition. But when you think of it, we use exactly the same rules as we did when adding base 10. And when we get to numbers greater than 9, we have to trade 10. When we get to numbers greater than 4 here, we have to trade 5, and so on. When we look at the algebra later in the semester, we repeat some of this stuff again, and people start to understand the patterns that are involved in place values. And yes, as you say, practicing a few, you'll be able to hopefully, work it out easier.